All right, hello everyone. Welcome to ECS 179, Gameplay Programming. Today we're going to have discussion on Exercise 3. And this is about the observer pattern, or you may have heard it as a watcher pattern sometimes. In web programming, it can be looked at in a way as data binding. And also the pub sub pattern, which is at the publisher subscriber pattern, which is at the heart of event based models. So this is a decoupling mechanism that allows you to watch and get asynchronously communicate with other processes in a way that does not involve a lot of coupling, a lot of hard links or function pointers or um, really brittle mechanisms to connect two bits of code. This is another tool in our growing toolbox of things that help us write, compartmentalize, and keep code manageable while still being powerful. This is a really well used, well known well known tool for us in this decoupling landscape and us making our code more powerful yet less brittle. All right, so I encourage you to get on GitHub Classroom. The link has been sent out via Canvas message. I will put it in the syllabus on Canvas. I will also send it out on Discord right after this discussion section. But for now, you have it in your email inbox. Please make a clone and follow along. So while you do that, I will talk about the description of the project, the goals that we have for it. So here, you can go to Gameplay Programming and Exercise 3 Observer Pattern. This is the repository that your assignment is based on. So going here, we have a project called PicMini. This is the base Unity project for the exercise. And we have some files here, the README, which has the description. And we have a couple WatcherDraw.io and Watcher SVGs. These are some images to help you interpret some of the stages in the exercise. All right, so first, this is a project that has a little more code. Things are getting a little more complex, so I'm giving some more description and a bit of a map of the project in the description file itself. So first, the goals of this project. I want you to gain experience with a few observer pattern variants. Two in particular, the watcher variant and the publisher subscriber pattern. We had a version of this, a lighter version of this, as an example in class the other day. So now we're going to deal with two versions of this pattern that you'll have to implement and add into a project. I appreciate the octopus emoji. Very, very Git. So there are some readings to do to help you understand what's going on with these design patterns. First is the chapter from Game Programming Patterns by Nystrom, the text we've been following in class, and also a C# article on the observer pattern by Eric Nodrius. So we have the observer pattern. I encourage you to go through this, read this. This will help buttress the concepts we talked about in class the other day. Basically, the implementation that we went over that you have inside of the GitHub repository, the publisher subscriber example follows this pattern, but also has some additional things going on. We also have this Haberdor website by Nick Adrius. It's been adding just a smattering of gameplay programming patterns with Unity in C Sharp. These are still pretty valid. These were made in older versions of Unity, but there's still plenty of good knowledge here. The core C Sharp fundamentals and the pattern fundamentals have not made this particular tutorial really any less valuable. So feel free to check those out. We also have a video from Microsoft's Visual Studio team on it's a YouTube video about the observer and publisher patterns. So this is also a good one to take a look at. I like to give a set of resources of different media and formats for you to deal with. So to get started on learning this pattern, you have our course materials, including the description that I gave in the project. You have the Nystrom book, you have the Nodrius reading, and you have a Visual Studio video. There's a ton of materials on this pattern out there in the wild. Dig in. All right, so this project is a bare bones implementation of top-down RTS style world that resembles Nintendo's Pikmin game. So this is all from scratch, from ground up. It's roughly inspired by both these genres. Give you a little taste on how they work and maybe a bit of implementation for you to test out on your own. If you're not familiar with either of these terms, Pikmin or real-time strategy, here the Wikipedia articles on them for your convenience. There's a lot of material on this genre and this particular artifact that we're based on, so feel free to check those out. And finally, we're using some C# capabilities that we have not used before in this class. So these are particularly delegates and functional programming in C# are something we will be using in this project. It'll be sort of the heart of how we pass things around in the observer pattern and use the watcher pattern. So you want to be familiar with delegates in general, and action delegates and function delegates. So delegates in general are first-class functions inside C#. So basically you can pass a function around mostly by its signature by using the delegate keyword, and you can pass them around to other functions. So we'll see how that works. Now, because these are pretty weighty constructs, their data type is a little interesting, right? So I'm sure you are all familiar with templated variable types in object-oriented programming. What we're doing here is we have two different subgroups of delegates, an action and a function. Actions are simply methods that do not have a return value. They're all void. So you see there's T, T1, T2, T1, T2, T3, all these various versions of action. These are simply templates for the number of parameters that your delegate member should have. Functions operate very similarly, except they also have a templated result. So if you need a return value from your delegate, you use the func. And if you do not need a return value, use the actions. Right, so there's plenty here to chew on. Should become familiar with those. Grading for the project. Stage 1 comes in 2 parts, each worth 10 points. Stage 2 comes in 3 parts, each worth, the first one's worth 15, and then 10 and 10, and then the last stage is worth 15 points. The due date is next Tuesday by 11:59 p.m. Just like the previous 2 exercises, we will be grading the master branch on your generated GitHub.classroom GitHub repository. So That seems to have gone well so far. Please continue to be excellent. All right. So let's take a look at the project and then we'll go over this description. All right, so if you open the PicMini project inside of your cloned repository, you'll see something that looks like this. So first we have the scene. So if you go to assets, we have materials, prefabs, resources, scenes, scripts, and objects for the universal rendering pipeline. We are using shaders for this project. I guess we'll go with the reason that this project looks a little different. We are using shaders, and those can be rendered inside the preview. That takes a lot of continuous processing power. I don't run with that all the time. So there is the draw mode functionality right here. Right, I have it set to wireframe. The shading mode is set to wireframe instead of shaded. The default that we use in other projects has been shaded. So now you can see shaded is a little more expensive. When you turn it on yourself, you'll be able to tell. What makes it expensive is we have a procedurally generated water running along the outside, just running at a reduced frame rate in preview mode, but it still takes resources. This is a noise-based shader for having a water effect that I constructed for you. We'll take a look at it. That's sort of like one of the extra. You can dig in and learn a little more components that I like to add to these projects. This shader effect is one of them. So this takes a lot of processing power. So wireframe will prevent that. We'll take that shader off of the preview mode so you can use your project a little more computationally efficiently while in edit mode. Okay. So taking a look, we'll start at the top with materials. So we have textures for our Animinies. We have controllers for the Animinies. The Animinies are the little Pikmin creatures running this. Let's see what I'm talking about. As soon as we reload the domain and build. So there's behavior for the Animinies. There's a shader for the water. There's a material for the shader to be applied to. And then we have a set of materials for the various world objects that you'll see, from the ground to the upper ground to the trees. Now here are the Animinies. You can see them all running around. They're little raccoonish creatures of 3 different color varieties, and they have a random size and they have a random scale. You can see the procedurally generated water in the back. You can see we have a little island, little square island for them to hang out on, various trees, and these blocks, the little homes for them to hang out in, are the orange Unity objects that we'll see here, the circle, square, and oval. So we have a small user interface here of buttons. We have circles and colors, and then we have send message. So the idea here behind this project, when it's fully completed, is you'll select something like a circle and a color. So this is a destination and a group. You'll send a message for this group to go to this destination. You know, it'll be the most recently clicked ones, and then they will travel there. That's what we'll end up hooking up for the PicMini movement. And we'll also do binding of their color, which we'll look at in a moment, which will update live using the watcher pattern. All right, so that's what the project looks like when it runs. These are the materials. It's fairly straightforward. We have some prefabs here, including the trees and the Animinies. We also have a baked version of the level. We have resources, in this case, are mostly audio. Note that there's a README where I keep the licensing and information for the assets that I gathered externally. In this case, Creative Commons Sound and Music. Here we have our scenes. First we have the PicMini play. There's a little scene that we use to generate the nav mesh for the Pick Mini to navigate around the low ground and to avoid the high ground. So this Pick Mini Playground is the scene you should load. That's the scene we have loaded right here. That'll be the one we'll be working in for this project. And we have the scripts. So first off, you'll see that we have a set of scripts. Well, there's one that's different from the others. We have a color bindings, which simply is 3 groups in the color pickers. You'll notice that each group is the same, represents the color of the Pick Mini groups that we have. Now, this color bindings is an instance of the color bind scriptable object. So we talked about scriptable objects earlier. One cool thing about scriptable objects, one of their capabilities that's very handy, is you can actually make an instance, an asset-based instance of this class inside of your assets folder. So right, we have color bind and we have color bindings. So if I right-click create, I can create a color bind object right here. So this will look through your assets and find the scriptable objects. You can make a new instance of color bind. When I do that, we have a new color bind object down here, our new color bind, and it has another binding. So we can change these using the picker to a bunch of different colors. Right, and so this is a different instance, a different saved instance of colors than the original color binding. So these are very handy. So let's say you have a weapon script or an armor script that you can use as like a piece of equipment in an RPG. You can then have a bunch of instances of that weapon or armor scripts, these equipment scripts. You can rename them like banded mail, full plate, studded leather, and each one of those can have different art assets linked to them inside of the scriptable object, the instance of the scriptable object. You can change their defense values, their weight values, their cost, etc. So you can make a bunch of instances of armors that you keep around and can use programmatically and as components. So it's quite a powerful system to Unity. I was very happy when they added this. It makes the ability for designers to work with your scripts much more user-friendly. All right, so that's color bind. We can look at the code for it here. You can see it on the side. But color bind, first off, when you use something external, something that's designed, something that's made by someone else, you should cite it, source it. So now here we have the color palette that we're picking is the Giant Goldfish by Mannequin Echo. And you can see it at colorlovers.com right there. So these are the colors that are associated with it. So we have a serialized field. Each one of these colors are serialized fields like we discussed before, meaning that they're private. So we have good security and encapsulation with respect to object-oriented programming, but we serialize it so it can, one, be saved to disk when you make an asset version of it. So it can be serialized or put into a text file that you can then read in later, or some sort of external file that you can then read in later. And you can also edit it in the inspector, right? And then finally, we have some simple functions, some accessors for the colors, which we'll be using. All right, that's color bind. Other things we need to look at here are the color watcher. So this will be part of your first step, the color watcher. And we give you some documentation, and we give you a watch function that you will be filling in as part of the exercise. And there's some instructions for it. So this is one of the classes that you'll be filling in, one of the scripts you will be filling in. Now we also have the script to generate minis. This generate minis scripts as we can see here, generate minis. On Awake, it just makes a bunch of minis for us. So we end up here having a bunch of prefabs of the minis generated. And each time we generate one, we play a sound effect. So the minis are called on the spawn object, which is right in the middle of the play area. So all the minis will be spawning right here at the beginning, and we are spawning the Animini, them based on the Animini prefab, and we're doing 50 of them. So taking a quick look at this. You can see we have 50 minis spawned, and then by default we give them a random location in the island to move to. So that's why they're all spreading out here. That's what the generate function does. It lives on the spawn object, which is where we'll be spawning the minis. And we'll take a look in a minute about iPublisher and iWatcher. These are the interface classes for the Watcher and Publisher patterns respectively. We have a mini controller, which simply is associated with each Animini to allow it to control itself. For instance, it has an awake function here. We hook it up, which you'll be dealing with the publisher manager, which is the heart of our publishing pattern. We have it randomize its body and randomize its group ID, so which color group it belongs to, which Animini group which pick mini group it belongs to, and you'll be modifying these for stage 1.1. And then looking here, we have this .agent.set destination. So another enrichment portion of this is putting a navigation mesh on top of the level for the navigable space, and then adding in a navigation agent as a component to the Animini's so that they can interact with that mesh and do path planning and avoid each other, avoid obstacles, and get from one destination to another. So this is where we set the destination, which is a vector 3 within this range. So this is basically the range of the island, and they want to make sure that we're actually on Y island. In this world, Y is up and the island is on the XZ plane. So we're randomizing the location, the initial location of the mini between -20 and 20 and -20 and 20 in the XY plane, or the XZ plane. All right. The change color function will be, you'll be using this. So this is how the mini updates its own color value to match its group color. Here's the randomized body function. We're basically giving it a random scale from 10% to full size. And we are then transforming the game object scale to be that randomly selected scale value. And then we are dealing with the onMove message to set a new destination for our agent. So this is the sort of like the user side, the decoupling side. So we just simply have this function onMove message, and we simply wait for that function to be called by the publisher, just like our jump function was, our onNotifies were called by the cube going closer to the origin in the class example. And then we'll take a look at the publish manager, iPublisher, and iWatcher in a moment. Actually, iWatcher we'll look at now because we're going to talk about the first stage. And it's very simple. If something is an iWatcher, it has a watch function that takes no parameters and returns no values. Simply calls watch. All right, back to the browser. So here we have a game scene objects in the hierarchy. You saw that we had a script home. The script home, as we discussed, is a conventional Unity object that holds scripts that manage levels, things. It's usually the more abstract or game logic concerns, such as score, experience points, things that don't have a physical manifestation. Those are usually tracked as a script component on this script home game object, which is simply it's basically just a transform. It's the bare minimum that you need to be on the scene. So it's basically a transform with a bunch of scripts hanging onto it. So you won't actually see it and it won't be rendered, but it will exist and be hooked into the pipeline, hooked into all of the messages that Unity sends game objects. And we have a canvas. So this one's, we saw this in exercise 1 if you took a look. The canvas holds the user interface elements, those, aka those buttons that you see at the top. Finally, we have next we have a cube, circle, and cylinder. These are the golden destination points that the Pick Mini can be set to. We have the spawn, which we looked at, which has the generate mini script. There's a nav mesh overlay used for path planning. And there's a bunch of prefabs in the level, including the geometry of the level and the trees. Notably, we have the procedurally shader-based water for texturing. We could take a look at that maybe at the end if we have time today. But you can see the shader graph asset for it here. So you can see a bunch of materials and things. You can see that it is an instantiate asset that is used to parameterize the visual shader editor, the shader graph editor inside of Unity. All right. And we went over most of these. We have assets and prefabs. We talked about the AniMini prefab. Feel free to check it out. There's an alternative Meeple themed prefab mini. It may take a little work to get going if you want meeples instead of raccoons, but that's up to you to deal with if you'd like. Now we have a button manager. This is when you press buttons and you press send, this is the script that provides it, that is the mechanism that reacts to those button presses to send out messages. The colorblind CS keeps the color bindings. This is a scriptable object. We have an instance of it called color bindings, which you can see here. We have a color watcher. So this we'll take a look at. This is a partial implementation that I give you that you'll be filling out for stage 1.1 or stage 1, the watcher pattern. This is a simple polling variant of the observer pattern. This is sort of like the 0th level version of it, the least complicated version of it, which is often used for things like data binding and keeping variables synced up across files, particularly in web programming or UI programming. We have generate mini script, which we talked about. We have the mini controller, which we talked about. Publisher manager. So it creates instances or an instance of the pub sub pattern for each of the 3 groups of the Pick Minis. So the idea here is that each group has its own publisher that they can subscribe to. So the group 1 Pick Minis subscribe to group 1, the group 2 subscribe to group 2, 3 to the group 3. So the AOE, the bluish color, cerulean color, is group 1, group 2 is the off-white color, and group 3 is the gold color by default. And each one of those has an instance of the publisher subscriber pattern so they can listen to their messages and move accordingly. You'll be filling this in. The iPublisher is an interface for the publishers to deal with. So this is the more advanced version of the observer pattern, called pub sub or publisher subscriber. We've talked about and had patterns before. This is where we have subscribe, unsubscribe, and notify. And that's basically the interface for a publisher. And iWatcher, which we've talked about, which just mandates the watch method. All right, so stage 1 watcher pattern. In this stage, you will create a script that will watch the color bind script. So it'll look for a color bind and respond to it. You'll be watching the color values in color bindings is the effect is the intent of this. You'll be using the polar watcher variant of the observer pattern to watch one of the three colors. So a watcher, watching a color and responding to it when it changes. If one of the three colors in the colorblind assets change through manipulation within the editor, so you can scrub the values and it can change, then the game object, which is basically we want the minis to update their colors, to change their colors based on the new color value in your color bindings asset. So that's section 1.1 gets us started. It's called the Pick Mini, always watching, always changing. So this exercise 2 had some goals and said implement these goals. This is a bit more of a follow along the steps recipe to completing these various watchers. So we give you an idea of what's going on at the front, and we sort of like lead you through an implementation. All right, so this portion of the stage, 1.1, requires modifications to the color watcher and mini controller scripts. So we want the Pick Mini to change their color. So they must be, and we want them to do so by watching the colorbind asset. So here is a diagram on how these are related. So colorbind has these functions called group in colors. So we had group 1, get group 1 color, get group 2, get group 3 colors. You can see those right here. Group 1, 2, 3. So they simply return color values. These are functions that return color values. And we pass those functions in as delegates. So we pass those as first class functions to the get color value inside of the color watcher instance. So this color watcher is the thing that watches for values and changes from the colorbind object. And then when a change is noted, it flags the callback. It'll invoke or execute the callback delegate, which is you are going to hook up to the color change method inside of the mini controller. So this color watcher simply looks at the color values from colorbind. When it changes, it wants to call this callback delegate to change the color of the mini controller. So the thing that keeps it polling to make it more of a unity is we will, inside of mini controller's update, call this watch function. So this is how it hooks into the life cycle. Mini controller has an instance of this color watcher to do its own watching for its own color purposes. We call the watch function inside of mini update just like we call the execute function for the command pattern inside the captain and pirate controllers. This is a common pattern for hooking these update based patterns into the Unity cycle. You want to do that inside the script. So this is the basic relationship between the classes. And we pass functions, or callback functions, as you often call these in user interface development, pass them as delegates into the watcher, which is sort of like this broker, the thing that does the function calls based on changes. All right, so here's an order on how to do things. So you can simply follow this order, create a new color watcher instance in the wake function. Basically, you want to hook up. This is a guide to hooking up all the data structures to look like this. The code that you'll be using for that. Here is the color watcher function. Notice there's not a lot here. We do give you the color watcher needs a few things to be set up properly. It needs a get color value function, which is one of those function delegates. So a function, as a reminder, is something that has a return value and takes parameters. In this case, it takes the parameter of a color class and simply returns a color value. Yeah, okay, the first parameter is the return value for the function when we pass it around. And then the action takes a color, doesn't return anything. So the action in our case will be the callback, which is the change color function in the mini controller. So basically, we will be looking at the get color value function, and when it changes, we'll be invoking the callback. So that's for you to call. This is like literally 2 lines of code that you have to fill in here. So I want you to understand delegates enough to be able to call this watcher pattern. Some of you that'll be intuitive. Some will be a little less intuitive on how delegates work. So if you think it's unintuitive to you, let's talk about it in class and Discord. Ask questions. You have the documentation. If it's confusing or you don't know how to call it, we'll help you out. Then we have our mini controller. So the mini controller has the change color function. This is that callback. This will be passing when we make the watcher, which you'll be setting up inside of here. So you want to watch the appropriate color group for each one of the watchers. So for instance, get group 1, you should hook up the watcher with color bindings. Get the color bindings method, get group 1 color. Then get group 2 color, get group 3 color. So when you set up the watcher takes 2 parameters. When you create an instance of it, you know, the color binding watcher function is the first parameter, second parameter being change color. Once you get these all fed up, and you get your color watcher set, and you add your watch function to update inside of your mini. So notice there's not update yet. You probably have to add one. If you call the watch function in update, you should be in pretty good shape. Right, back to the browser here. Now that is basically the task for stage 1.1, 1.2, pick mini peeping periodically. So notice we're doing this polling a lot. We're checking every frame for color changes. Well, for those of you who have done hardware-based polling or other polling mechanisms, this can be expensive. So we want a way to tune how much computation power we're spending on polling. In this case, I want you to add inside of the update in the mini controller, I want you to add a throttle. So I want you to have a small timer which elapses, and you can spread out the in time. You can delay watching by so many seconds. So you would only call watch when your timer, which is set by time since checked, or set by throttle. So throttle should be the field in the mini controller script that you add, which should be how the delay time between caller checks, between watch calls that your pick mini should use. So you can set it to a second or two, and then will update, fairly slowly on a second or two cadence upbeat. It will check the color watcher, and your pick minis will update their color. If setting this to small values to be more responsive but cost more resources, large values to be less responsive and cost less resources. So this is a good part of this pattern for performance for tuning. All right, stage 2, the pub sub pattern. So here we are focusing on the publisher subscriber variant of the observer pattern as stated previously. 2.1 is publish, subscribe, notify, and profit. So this is a lot of template, a lot of boilerplate code you're setting up, a lot of plumbing and connective tissue that you're setting up, creating publishers. So you have to make a new file here, publisher CS, that implements the iPublisher interface. So you should have an understanding of how this pattern works, because you'll have to make a subscribe, unsubscribe, and notify method inside of your own publisher.cs. And your subscribe should do this. You should subscribe, add a delegate to your collection. So this will be the callback that will exist on the mini controller. And this will be the function that when you want to notify all of your subscribers as a publisher, you want to call this function which is the effects sending them the message, which is notifying them. And then you want subscribe and unsubscribe. You want to be able to add and remove them from the collection. Notify is when they actually you want to send a message to your subscribers. You want to notify them that your thing has happened. The event is now. All right, purveying publishers. So when you have made this class, notice we haven't used it yet. When you're making this class, you'll need a publisher manager. So we have 3 publishers, so we need to manage all the publishers in some way. We're going to make a publisher manager class, which is our central broker for all 3 of our all 3 of our publishers for each group of Pick Mini. They should all have their own subscribe and unsubscribe methods, and you should have the send message with publisher function, which we'll talk about later. Subscribe to group. You should check which group ID has been passed, subscribe, and add their appropriate subscribe and callbacks. And unsubscribe, it should take your group ID and you should unsubscribe that particular Pick Mini from the publisher. Amassing messages. So here is where I hook in. This is the final hook after you have this stage done. You'll be able to actually send messages and have your Pick Mini respond. So you want to use your send message with publisher function within the publisher manager.cs. And that should hook up the notify action. So you should be able to correctly notify or give a new position as a destination to each of the Pick Mini subscribed to that publisher. So move the entire group to this location, or move this other group to this other location. This is hooked into those user interface buttons. Let me show you what that looks like. And we'll go to the key. Observer pattern, Pick Mini playground. Here's the key. Maybe? That key took an awfully long time to load. May have to reload the key. Yeah, it looks like it was not happy. All right, I'll show you what that looks like after the key loads, but let's continue forth with the last section here. Stage 3, a mini tale of life and death. So my previous TAs had a little fun with this. In a virtual world, Pick Minis exist on the physical plane. Much like their fictional counterparts, Pikmin, Pick Minis have a finite existence. They are not immortal. Pick Mini might love changing their color and moving to Pick Mini might love changing their color and moving in 3 different destinations. However, their lifespans range from roughly 10 to 40 seconds. They don't live very long. Luckily, they can reproduce asexually. All they need is a Fire 2 command. So when a player enters Fire 2, right click or left alt, the Pick Mini should spawn on their ancestral home, known as, in the common tongue, as spawn. So basically Fire 2, we want to spawn a new instance of Pick Mini, and it should be hooked up appropriately to all the publishers, subscribers, and watchers. So you should create a script called Pick Mini Spawner and attach it to the spawn game object. This spawner should look for Fire 2 inputs in its update function, and then it should instantiate a new Animini. And when you instantiate a new one, you should play the sound effect, and you can do that with this line of code. So to summarize, make a Pick Mini spawner.cs mono behavior and add it to the spawn object in the hierarchy. That should, in its update, it should respond to Fire 2s, or you could have it respond to on mouse click messages. So it should look for Fire 2s and generate new Animini prefab, like you've done several times already, making prefabs of making instances of prefabs and putting them on the scene and manipulating them. The mini controller CS script should be changed, so you need to add to the script a way for the Pick Mini to have a lifespan that randomly is between 10 and 40 seconds. And after they live that long, the enemy should be destroyed, and you should make sure to remove it from from the publishers as well, so you don't have you're not calling null references. Now you have a few functions. You can use input.get button or input.get button down to react to Fire 2, like we've done in previous projects. So this is where we're asking you to do, make something from scratch on your own. Let's see if we load it. Mini. Here we are. Here's the key. Great. Okay. Project. So yours may look like this when you load it up. We're going to load the Pick Mini playground scene. Let's put the scene and the game object in the same tab here. Let's make our scale appropriate. Okay. Scene, game, let's turn off the wireframe shaders. Okay, great. Let's give it a play. Let's take a look. So first we'll take a look at the Watcher. So this one I didn't implement the lifespan. Oh, what's going on here? Do we have something disconnected? It's like not everything loaded properly. Okay, there we go. There we go. It just took a moment. So we have our Pikmin. They're moving around. They have their different colors. Now what we can do is look at our Watcher. So what should happen is when we go to our color bind instance, our color bindings, we should be able to change these, and the different Pikmini should change their color. So if we changed the blue color to a darker blue, you'll see that the Pikmini update their color live. So we have that Watcher implemented. So group 1, group 2. What's another good goth color? Like a dark purple. There we go. We have our goth Pikmini. So we have the Watcher that can change their colors. So that shows that you have implemented the Watcher pattern. Now, to have the completed stage 2, you need to be able to have all the Pikmini of a group move to a location. So I click circle 1, color 2, send message. Hey, look at that. All of our Pikminis are moving, that are of that group are moving to that location. So we'll send the red to square, and we'll send the purple, the group 3 to oval. There we go. See this little one over here was all, go little guy, you can make it. There he is. All right. And so you can send them other signals, right? We'll send black to oval. Oh no, let's send it back to circle. Oh no, back to oval. So you can get them a bunch of commands. They can all go to the square if they want. But all of them be happy together. Color 2 square, color 1 square. So they're all hanging out. Now when I right click, Fire 2, I'm adding a whole bunch of minis. Each time I do it, there's a sound effect. So notice when these minis are generated, they're given a random location to go to. You can group them all up. All of them respond to the messages. All right. And so you can see this is part of that stage 3. We're spawning with fire with right click. Because I'm talking about this and we need a live example I can talk over, they are now, these mini do not die within the 10 to 40 second range. So yours, you should click on a mini. Let's say you randomly generated between a value of 21, which is between 10 and 40. This Pikmin would disappear, would expire after 21 seconds of after the generation happened, right after you right clicked and generated it. So each one of them, you can see have a different size, different scale, go to a different location, are randomly generated in a group. There you go. So if you have this capability that we've shown here, along with them expiring in their 10 to 40 second lifespan, then you will have completed exercise 3. All right. It is now 9 o'clock. Or do you have any questions about exercise 3? This one is a little more technically complex than exercise 2 and exercise 1, but it's also more of a recipe and less of open problems. So a lot of people find this exercise to be one of the easier ones in the class. Right. I don't see any questions, so I will stop the recording. Feel free to look at the project, download it, get started on the GitHub Classroom version, and get familiar, ask questions. We're just in the overview now. You may just need a moment to spend and understand, to grok the project yourself, to ask questions. All right. I'll stop this from playing. Thank you for your time as always, and I will see you in class today. Take care.